In a riveting display of academic ingenuity meeting defense imperatives, the Indian Institute of Technology Kanpur IIT-K has spotlighted scale models of next-generation stealth unmanned combat aerial vehicles UCAVs during a recent seminar on background unmanned combat UAV dynamics. Hosted under the aegis of IIT-K's Aerospace Engineering Department, the event, captured in vivid visuals shared across academic and defense circles, reveals two intricately crafted prototypes that mirror the flying wing architecture of DRDO's secretive Ghatak program. These aren't mere showpieces, they're vital testbeds, generating aerodynamic and flight data to refine an indigenous autopilot system for the full-scale UCAV. Underscoring IIT-K's pivotal role in India's self-reliant drone ecosystem, the showcase, held in late October 2025 amid heightened focus on autonomous warfare post-Aero India, aligns with IIT-K's burgeoning defense portfolio. Through its incubated startup VU Dynamics and direct collaborations, the institute is bridging the gap between lab simulations and battlefield-ready tech, potentially accelerating Ghatak's timeline toward first flight in 2026. A close examination of the seminar visuals, featuring high-resolution photos against IIT-K's hallmark yellow-branded backdrop, highlights two scale models perched on a simulated runway, evoking the stealthy silhouette of a Predator drone. Both embody the tailless, blended wing-body design synonymous with low-observable platforms, sharp leading edges for radar deflection, serpentine air intakes buried in the upper fuselage to minimize infrared signatures, and smooth, curved undersides optimized for subsonic stealth. The frontal profiles are strikingly congruent, sporting diamond-shaped inlets, twin, semicircular ducts flush with the wing's leading edge, angled to shield compressor faces from ground clutter, a hallmark of Ghatak's swift, stealth wing flying testbed, demonstrator, blended canopy, a subtle, radar-absorbent hump suggesting sensor bays for electro-optical targeting or synthetic aperture radar, SAR, with no protruding pits for vulnerability, scale fidelity, estimated at 1:10 ratio based on wingspan roughly 1.5 meters, these models replicate the 13-ton Ghatak's 14-meter span, complete with foldable wingtips for carrier ops. Divergences emerge aft, hinting at iterative testing phases. Model 1, white with blue accents, a pristine, gloss-white finish on the upper surfaces for visual stealth in cloudy skies. Paired with a conventional rear exhaust nozzle. This variant appears tuned for baseline stability, likely used in wind tunnel runs to baseline drag coefficients at Mach 0.8. Model 2, gray with dual nozzles, darker matte gray for all-weather camouflage, featuring twin, vectored nozzles suggestive of 2D thrust vector control, TVC. The nozzles pivot in pitch for enhanced post-stall maneuverability, critical for evading missile locks in contested airspace, powered perhaps by a scaled Kaveri derivative engine, KDE, mock-up. IIT-K's Fluids Lab, known for hypersonic flow simulations, would have leveraged this for TVC efficacy data under high-alpha conditions. These models, fabricated via additive manufacturing and composites at IIT-K's National Wind Tunnel Facility, NTWF. The real intrigue lies in the back-end, IIT-K's tie-up with the Defense Research and Development Organization, DRDO, to co-develop the Ghatak's neural network-driven autopilot. Under a 2024 MAU extended in March 2025, IIT-K's Systems Control and Automation Lab provides the algorithmic backbone, while Aeronautical Development Establishment, ADE, integrates it with Ghatak's avionics suite. The scale models serve as digital twins. Their flight logs training reinforcement learning models to handle edge cases like turbulence over the Himalayas or electronic jamming near the LAC. In essence, what unfolded at IIT Kanpur is far more than an academic seminar. It is a glimpse into the future of India's autonomous warfare capability. With each flight test, each dataset, and each algorithm update, India moves one step closer to deploying a fully homegrown stealth UCAV capable of penetrating enemy airspace, conducting deep strike missions, and executing electronic warfare scenarios, all while staying invisible. And behind this groundbreaking evolution stands a university lab, a team of inspired researchers, a growing network of defense partnerships, and two small yet powerful scale models that symbolize India's entry into the next era of aerial combat.